Hello students, your teacher here, Mr. Sarasinski, another episode of Algebra 1, and we're getting so close. Review packet number 4. Okay, so we got 4, 5, and 6. 6 is to be the last one. 6 will be focused mostly on quadratics. So 4 is systems of equations. Okay, 5 we're going to be looking at, exponential functions and polynomials. So this packet is all about systems of equations, linear inequalities, and systems of linear inequalities. And so we start off just with what is a system? Okay, so a system of linear inequalities, a system of equations is two, I don't need a hyphen there, two linear equations on the same graph. Okay. All right. And so if we have two linear equations on the same graph, then there's 3 possible outcomes. Okay. One outcome is that there's one solution. Okay. And you remember the solutions are ordered pairs. Okay. So it's where the 2 lines intersect. Okay. So there's one solution for intersecting lines. And the solution is the ordered pair of where they intersect. There is another possible outcome where there are no solutions, and we can use a 0 with a line through it as the symbol for no solutions. And this is when there are parallel lines, because if they're parallel, they never intersect. And then another possible outcome is that there are infinite solutions. Okay. And we use the infinity symbol. It's like a sideways 8 for infinite solutions. And this is for when there are identical lines. So this would mean that they overlap. Okay, it's the same line. Okay. And so I just wanted to put these would be overlapping. All right. So in this first topic, okay, so we've defined what they are now. And in this first topic, we're solving them using graphing. Okay, so there's 3 ways to solve systems of equations. There is graphing. Okay, you can just graph them and find where they intersect graphically. There is substitution, and this is when you solve, or if the equation's already solved for one variable, then you can substitute what that variable equals into the opposite equation and solve for one variable, and then substitute it back in to solve for the other. And then the third way to solve systems of equations is elimination. And this is where we added or subtracted one equation from the other in order to get one of the variables to cancel out, solve for the remaining variable, and then substitute that back into one of the original equations to solve for the other variable. And this may be confusing to hear in words, so let's just put it to action. All right. Now, in some of these, and I know in number 3, not so much, but in number 4, we're going to have to convert from standard form, which is ax plus by equals c. This is standard form, to slope intercept. Okay. Which is y equals mx plus b. And, anytime we're graphing, this is the form that we want. So a little extra work in some of these just to get it in that form, but, don't lose focus of the real objective, which is graphing these lines and looking for where they intersect. So number 3, we'll start out with the first equation. And so I start at the y-intercept, which is 2, and the slope is -3. That means I go down 3, right 1. down 3, right 1. And when you're doing systems, if you're graphing systems, add plenty of points, okay? You technically only need 3 points or 2 points to make a line, but you know, if you're not making straight lines when you make your line, and let's just be honest, they're hard to make straight, just make extra lines. Just kind of take some of the guesswork out of it. So there you go. I've got lines going in both directions, and I can connect my dots. Okay, arrows at the end to show that it continues to go in both directions. And now I'm going to graph the other line. I'm going to do this in red. So it started at -6 on the y-axis. And the slope is 1, so that's up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And since I've already found the place where they intersect, I'm going to go ahead and connect the dots. Arrows at the end to show that it continues to go in both directions. And the place where they intersect is right here. So where is that on the grid? Well, that's 1, 2... -1, 2, 3, 4. So 2, -4 is the solution to this system. All right, number 4. I'm going to convert this equation to slope-intercept form, and it's the same process each time. Subtract 2x, so we're solving for y. This one's actually going to be a little easier. Y equals -2x plus 1. Because y doesn't have a coefficient in this equation. So I don't have to divide by the coefficient of y. And I can go ahead and graph this. Start at 1 on the y-axis, and the slope is -2. That's down 2, right 1. 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 And I'm going to go back to my y-intercept, and I'm going to go opposite slope. So up 2, left 1, up 2, left 1. And it just kind of continues. Look, if you're making dots and they don't look like they're in a line, you're doing something wrong, okay? So there's my dots. Okay, arrows at the end to show that it continues in both directions forever. And now let's do the second equation. We're going to convert it to slope-intercept form. So x minus 2y equals 18. We're going to subtract x. And get -2y equals -x plus 18. Divide by -2. So y equals, I'll write it down here, 1/2 x minus 9. So I start at -9, and the slope is up 1 over 2. Up 1 over 2, up 1 over 2, up 1 over 2. Connect the dots. So the place where they intersect is right here. And that is at, let's see, 1, 2, 3, 4, -1, 2, 3, 4, 5, 6, 7. So it's at 4, -7. That is the answer. All right. 15, or I'm sorry, not 15. 5 and 6 are for you. Okay. In number 5, the first equation has to be converted, and so does the second. But the second, all you have to do is divide by the coefficient of y to simplify that and get it in slope-intercept form. And then in number 6, you're going to have to convert both of them fully. Okay. Nope, no problem though. All right, so topic 3, systems of equations algebraically. All right, so here we go. Now we're going to use substitution or elimination, and I'm going to go ahead and say that elimination is best for 7 through 9. Substitution is best for 10 through 12, okay? So, you know, if you want to do it one way or the other, that's fine. I'm just trying to make a suggestion. For number 7, we can add or subtract, okay? So just as a reminder, anytime we're using elimination, we're trying to get one of the variables to cancel out by adding or subtracting, Okay, so in number 7, I could subtract those two equations and get x to cancel out, or I could add those two equations and get y to cancel out. I prefer to add, so in number 7, I'm going to add. Now, it's not going to be the same thing I do in all of them, so I'm going to add these two equations, okay? X plus x is 2x, right? Because there's a 1 there. So 1x plus 1x is 2x. Positive y plus negative y cancels out. And negative 4 plus 2 is negative 2. Divide by 2 to solve for x, and x equals negative 1. Once you get one of the variables, you can substitute it back in for x, okay? So I'm going to put that back in for x, and I'm going to get 1 times negative 1 plus y equals negative 4. So that's negative 1 plus y equals negative 4. Add 1 on both sides to solve for y, and y equals negative 3. So the solution, negative 1, negative 3. All right, I'm going to leave 8 for you guys. We're going to move on to number 9. So in that first equation, when I used elimination, I didn't have to do any work. All I had to do is choose to add or subtract. But sometimes we have to multiply the equations to get one of the variables to cancel out. So in number 9, I have to multiply the first equation by 5 and the second equation by 4 in order to get the x terms to cancel out because they have different coefficients. I could also do this for y and multiply the first equation by 4 and the second equation by 3. I'm choosing to do the x's, okay? So you got to do a little work on the front end. It's not hard. Just multiply the whole equation by that number. So this is going to be 20x plus 15y equals negative 5. And then I'm going to multiply the bottom equation by 4. So 20x plus 16y equals 4. And I'm going to subtract to get the x terms to cancel out. 20x minus 20x is 0. 15y minus 16y is negative 1y. And negative 5 minus 4 is negative 9. Divide by negative 1 to solve for y, and y equals positive 9. Once you have what y equals, you can plug it into one of your original equations. You don't have to use your newly multiplied by equations and get your value for x. Okay, so I'm going to put it in the second equation. 5x plus 4 times 9 equals 1. 5x plus 36 equals 1. Subtract 36 from both sides. And 5x equals negative 35. Divide by 5. X equals negative 7. So the solution, the place where these two linear equations intersect on a graph, is at negative 7, 9, which is in the fourth quadrant of the coordinate plane. All right, so number 8 was for you to do for homework, just like 5 and 6. And I'm going to do 10 and 12. I'm going to leave number 11 for you guys. So number 10, I'm going to take what y equals in the first equation and substitute it for y in the second equation. So I get 4x. This is substitution, okay? So we start out by substituting. Now, the reason I knew why this was the technique I wanted to use is because in both of these equations, it's already solved for y. So I already know what y equals. I don't have to do any work. Look at number 11. The first equation is already solved for x. So I can take what x equals and substitute it in for x to the second equation. Same thing with number 12. Second equation is already solved for y. So I can take what y equals and substitute it for y into the first equation. This is kind of how you know, all right, what's easiest to do and when. If it's already solved for a variable, just take that and substitute it, okay? All right, so let me erase some of those marks. And let's finish here. 4x plus 2 equals x minus 1. Subtract x from both sides. We're going to solve. And we get 3x plus 2 equals negative 1. Subtract 2. 3x equals -3, divide by 3. Okay, so x equals -1. Once you get what x equals, you can substitute it back into either of your original equations. So y equals 4 times -1 plus 2. That's -4 plus 2. That's -2. So the solution, the place where these two lines intersect on a graph, is -1, -2. Last one in this section. All right, so we're going to take what y equals. We're going to substitute it in for y to the first equation. So we get 2x plus 3 times 5x minus 27 equals 4. And I'm going to distribute. So I get 2x plus 15x minus 81 equals 4. Combine like terms. That's 17x minus 81 equals 4. And then we're going to add 81 to both sides. 17x equals 85. Divide by 17. And the answer is x equals 5. Once you get what x equals, substitute it back in. I'm going to do the second equation. Y equals 5 times 5 minus 27. That's 25 minus 27. That's -2. So y equals -2. The solution, the place where those two lines intersect on a graph, is at 5, -2. And that's it. All right, so we've got some application problems now. All right, so in application problems, you got to do a little extra work. You got to interpret. You know, that's a hard thing to do sometimes. You got to interpret these words into equations. And you need two equations because these are still systems. And then once you've got your equations, then you have to solve them. You got to choose the best method. And, you know, for these, we're going to be using substitution or elimination, depending on what we get. So let's start off with interpreting. And I think the best thing to do when you're interpreting, first thing is to define the variables. Okay, so what is x? What is y? So I'm going to read this, number 13. All right, so I'm going to do 13 and 14 and 17. Your guys' work will be 15 and 16. So number 13, Brianna bought 3 bottles of ketchup and 2 bottles of mustard, and for $11.85. It's not a very good sentence. Logan bought 2 bottles of ketchup and 5 bottles of mustard for $13.73. Find the cost of each. So X is the cost of 1 bottle of ketchup, and Y is the cost of 1 bottle of mustard. Okay, so Brianna's equation, she bought 3 bottles of ketchup and 2 bottles of mustard for $11.85. And Logan bought 2 bottles of ketchup and 5 bottles of mustard for $13.73. How much does each one cost? So I'm looking at these coefficients in my variables and I'm thinking elimination, okay? Because neither one of these is already solved for a variable. And if I start trying to divide these out, I'm going to get a lot of fractions to solve for a variable, so I don't want to do that. I'm going to take this first equation and I'm going to multiply it by 2. And I'm going to take the second equation and multiply it by 3 to get the coefficients of the x terms to cancel out, okay? So if I multiply these, I get 6x plus 4y equals $23.70. And if I multiply the second equation by 3, I get 6x plus 15y equals $41.19. Okay, so that worked out pretty good. Now I'm going to subtract them. 6x minus 6x is 0. 4y minus 15y is negative 11y. And 2370 minus $41.19 is negative $17.49. Divide by negative 11, and y equals $1.59. So we know the cost of one bottle of mustard. Now we need to figure out the cost of the ketchup. So I'm going to take what y equals, I'm going to substitute it back into my original equation and solve for x. So I'll do that in a different color. 3x plus 2 times $1.59, because that's how much mustard costs per bottle, equals $11.85. 2 times 159 is $3.18. Subtract 318 from both sides. And 3x equals $8.67. Divide by 3. And x equals $2.89. So the ketchup costs $2.89, the mustard costs $1.59. All right, number 14. And technically, you know, the ordered pair where these intersect is $2.89, $1.59. Okay. The Boy Scouts are selling 2 types of popcorn as part of a fundraiser, butter and caramel. I know that I would be all about the caramel. Love me some caramel corn, Cracker Jacks all day. Butter popcorn sells for $5 per bag, and caramel popcorn sells for $6.50 per bag. So far, Alex has sold 40 total bags and raised $221. Find the number of bags he has sold for each type of popcorn. So this is, you know, that question kind of helps us define the variables, which is why I underlined it. So X is going to be number of butter bags, and Y is going to be number of caramel bags. All right. So my first equation is going to be 5x plus 6.5y equals 221. And my second equation is going to be x plus y equals 40. So if he sold 40 total bags, I need to know the combination. So x plus y can equal 40. And if I have the amount that they cost, then I can say, well, 5x plus 6.5y equals 221, because that's how much he's sold so far. And now I have 2 equations. Now, I personally feel like this one is going to be easier to continue just to do. You know, you can do substitution, which, you know, I can see in that second equation, it looks pretty easy to solve for a variable. And so I'll do that. I'm going to do this one in substitution. I think it would be just as easy to multiply this bottom equation by 5 and then get the x's to cancel out, okay? So I'm going to just solve this bottom equation for x. I'm going to subtract y from both sides, and I'm going to get x equals negative y plus 40. And then I'm going to take what x equals, and I'm going to substitute it for x in that first equation. I'm going to use a different color. So we get 5 times negative y plus 40 plus 6.5y equals 221. I'm going to distribute my 5, so I get negative 5y plus 200 plus 6.5y equals 221. Combine like terms. Negative 5 plus 6.5 is 1.5y plus 200 equals 221. Subtract 200 from both sides. And 1.5y equals 21. Divide by 1.5. So this is a 1, 2, 3, 3-step equation. Well, 4 really, you got to combine like terms. So 21 divided by 1.5 is 14. So y equals 14. So we know he sold 14 bags of caramel popcorn And I can substitute that back into my second equation. So I get x plus 14 equals 40. And, you probably don't even need to solve this to know that x equals 26. So the solution, 26 comma 14. All right, so here we go. 26 bags of butter popcorn, 14 bags of caramel popcorn. Not how I expected it to go, but I got a sweet tooth. So anyway, 15 and 16 are for your homework. Okay, try those. They're just like 13 and 14, right? The same types of equations, the way you set them up, okay? Number 15, you got x is the number of 6-person tables, y is the number of 4-person tables. So x plus y equals 37, 6x plus 4y equals 180. And then in 16, x equals the cost for each call minute, y equals the cost for each text message. This is just like number 13. Your two equations are 95x plus 207y equals 2355, and 162x plus 124y equals $17.26. And I used for those elimination, and you have to multiply the top equation by 95, the bottom equation by 162. You get some big numbers, but if you do the math, it all works out. So, all right, so for number 17, Camille has a collection of 61 nickels and quarters worth $6.85. How many of each coin does she have? So X is the number of nickels, and Y equals the number of quarters. All right, so she's got 61. That means X plus Y equals 61. And then there were $6.85. So 0.05X plus 0.25Y equals $6.85. Now, I feel like in this example, we're going to do elimination. No, substitution. All right, so I'm going to subtract. I'm going to solve for X, subtract Y. So X equals negative Y plus 61. All right, now I'm going to solve. So I'm going to substitute what X equals for X in the second equation. And I'm going to use a different color. 0.05 times negative Y plus 61 plus 0.25Y equals $6.85. Distribute, you get negative 0.05Y plus $3.05 plus 0.25Y equals $6.85. Combine like terms. Negative 0.05 plus 0.25 is 0.2Y or 0.20 plus 3.05 equals $6.85. Subtract 305. And you get 0.2Y equals $3.80. And then divide by 0.2. $3.80 divided by 0.2, Y equals 19. Okay. Once you have what Y equals, take it and substitute it back into the original equation. So X plus 19 equals 61. Subtract 19 from both sides. And X equals 42. So there were 42 nickels and 19 quarters. All right, moving on. Topic 5. So in topic 5, we're graphing linear inequalities. And there's a couple rules that I want to remind you of. I'll squeeze them in right here. So I'm going to box off a little section. If it's greater than or equal to, less than or equal to, you have a closed dot. If it's greater than or less than, you have an open dot. If it's greater than or equal to or greater than, you shade above. And if it's less than or equal to or less than, you shade below. Okay, so those are kind of the rules that we need to remember, because the solution to inequalities isn't one point, or in inequalities, it can be a lot more solutions, broader choice for solutions. And you'll see what I'm talking about. 18 and 19, I'm going to leave for you. One part of this is also, just like before, converting from standard form ax plus by equals c to slope intercept, y equals mx plus b. So like in number 19, you got to solve for y. Subtract 5x, divide by 3. But you'll see that again in number 20, which is where I'm going to start. So 18 and 19 are for you. That last page, what I should have put is, let me fix this. I didn't even think of it till now. What I should have put was a solid line, and greater than or less than is a dotted line. That's what I meant. Okay. All right. Sorry about that. Let's go on to number 20. And at number 20, I need to get this in slope-intercept form, so I need to subtract x. Okay, whatever you do to one side, you do the other. Oh, I forgot to mention one really important rule. If you multiply or divide by a negative on both sides, you have to flip the inequality sign. Okay, that's an important rule. If you don't do it, you will be wrong. So I'm about to do it here. Negative 2y is less than or equal to negative x plus 8, so nothing's changed yet. But I'm about to divide both sides by negative 2, and when I do that, I have to flip the inequality sign. So y is now greater than or equal to positive 1/2 x, because a negative and a negative make a positive, minus 4. So I start at negative 4 on the y-axis. 1, 2, 3, 4. This is graphed just like an equation. Since it's greater than or equal to, I have a solid line. The slope is 1/2. That's up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2. Connect the dots. Okay. And since it's greater than, I shade above. So all this area above is what gets shaded. And the reason I'm shading this is because all the ordered pairs above this inequality, all the points, if I were to go and choose a point up here, and I were to substitute those values in for x and y, they would make that inequality true. Okay, so these are all the solutions, including all the points on the line. All right. So that's what I meant by having just a broader number of solutions than an equation. An equation is only the points on the line. All right, 21. Y is greater than 1. Well, y is greater than 1. This is going to be a horizontal line. Okay, so we make a dot at 1. Since it's greater than, this is a dotted line, not a solid line. Okay, that means that the points on this line are not solutions to the inequality. Okay, and since it's greater than, I shade above. That's it. Easy peasy. If it's x equals or x is greater than, that's a vertical line. And you have to substitute a point into the inequality to see if it makes it true. Like, for example, if I chose this point for this inequality, that's negative 2, negative 2. Well, I can only substitute the y value. So negative 2 is greater than 1. Well, that's false. And actually, any point that you choose down here is going to make this inequality false. And so if you choose a point, and you don't remember the rules, but you remember you can choose a point and substitute it in, and the point makes the inequality false, then you shade to the opposite side. If you substitute a point in and it makes it true, like for example, I choose this point, which is 0, 4. Well, 4 is greater than 1. That's true. So that's the side that I need to shade to. Okay. All right, so that takes us into our systems of linear inequalities. And the same rules from last apply here, okay? Greater than or equal to, less than or equal to is closed dots, or I'm sorry, I put closed dots. All right, so all those rules still apply. So here we go. Of course, they're not going to be in slope-intercept form. I'm going to go ahead and do 22 and 25. You guys will have 23 and 24 for your homework, okay? So 22, you got to convert both of these to slope-intercept form. X plus y is less than -1. Subtract x. This one's going to be pretty easy because y doesn't have a coefficient. Y is less than -x minus 1. All right, sorry about that. Just got made aware of the shooting that was at Austin East High School. It's terrible, guys. Terrible, terrible, terrible. Guns are not the answer. Violence is not the answer. All right, anyways, let's try to finish this up. So I've solved one. I'm just going to go ahead and do the other here. So x minus y is greater than 8. Subtract x. Negative y is greater than -x plus 8. And then we have to divide by -1. So when we divide by -1, remember that rule, flip the sign. Y is less than positive 1x minus 8. So now I have my two inequalities. I'm going to go back. I'm going to graph the first one. So y is less than -x minus 1. Start at -1 on the y-axis. The slope is -1, so I go down 1, right 1. 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 And then I'm going to go back and go the opposite direction. Up 1, left 1. Up 1, left 1. Up 1, left 1, up 1, left 1, up 1, left 1. And since this is less than, it's dotted line, so that means all the ordered pairs along this line do not make that inequality true. Okay. And since it's less than, we shade below. All right, so all these are the ordered pairs that make that inequality true. All right, and now I'm going to do the other inequality. So start at -8. There's 10 boxes in each section, so I went ahead and counted so that I could count 2 away from the 10 instead of counting down 8. It's faster. Up 1 over 1, slope is 1, so up 1 over 1, up 1 over 1. Now here, since these are linear inequalities, it's not the place where they intersect. Okay, it's where the shading intersects. Since this is less than, it's going to be a dotted line. Okay, and then I'm going to shade below because it's less than. So, oops. Shade. Okay. Now where the shading overlaps, that is where the solutions are. So all the ordered pairs where the shading overlaps make both inequalities true. So, you know, if somebody could ask you, does the point 6, -9 make those inequalities true? And you could say yes, because it's in that area, okay? So that's one way you can narrow down some solutions. So there are all these ordered pairs in this section and going down, okay? All right, so number 25 and 23 and 24 for you. I only have one inequality to convert from standard form to slope-intercept, so I'm going to go ahead and do that. 4x minus 5y is greater than -35. Subtract 4x from both sides. -5y is greater than -4x minus 35. And divide by -5. Okay. Y is less than, got to flip the sign, positive 4/5 x plus 7. Okay, so let's go ahead and graph this one. Start at 7 on the y-axis. and the slope is 4/5. Now, if I try to go 4/5, I'm going to go off the grid, right? It's going to be somewhere around here. But I can do the opposite slope. So positive 4/5, it's like going up 4, right 5. I can go down 4 and left 5. And that's the same. Okay, and I can probably do it one more time. Down 4, left 5. Now, this is less than, so it's a dotted line. Okay, arrows at both ends. And since it's less than, I shade below. So all this area is where the solutions are for that one inequality. Okay. And now I can graph the other. X is less than or equal to -3 is a vertical line at x equals -3. And since it's less than or equals to, it's a solid line. Okay. And this is one of those where you have to really choose the point. So I like to choose the point 0. So 0, is 0 less than -3? Well, no, 0 is greater than -3. So I don't shade to the right side of this line. I shade to the left side of this line. Okay, so I shade to the left side of this line. And the place where the shading overlaps is the place where the solutions are to the system of equations, to both equations. Okay, so the solutions are right in here. Okay, I am your teacher. This is the way.